Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be flying Zurich, Switzerland, Germany. They're coming back to the Zurich International Airport runway 14 for an ILS localizer landing zone. And I'm in the cockpit for the pre-takeoff preparation of the Quality Wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments that displays on the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude selected by the autopilot flight director system panel, the target altitude and the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, and the vertical rate of climb descent of the aircraft in tens, hundreds and thousands feet per minute, or the steepness of the barometric angles in degrees and can climb and descend. We have also the radio altitude above the ground level and the artificial horizon with the altitude indicator, the pitch ladder degrees and the bank angle in degrees. Also we have the ILS localizer, the instrument landing system. So we use the ILS localizer, the instrument landing system that transmits from the radio frequencies and then of the threshold runways we use for takeoff and for landing. They transmit the radio frequency that is received from the onboard antennas of the aircraft and can help us align, so we can align with the horizontal localizer and the vertical glide slope. You can see the ILS localizer displayed in the primary flight display. So we'll have to tune for each runway its own radio frequency, and also use we're gonna use the magnetic north pole heading of 136 degrees for this runway. The runway 14 in Zurich International Airport, Lszh in Switzerland. So we're gonna use. Also, we have the ILS localizer crossbars displayed in the primary flight display, the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode associated with the autopilot and the auto throttle. Later on vertical navigation modes. We have also the HSI that displays the horizontal and the vertical. You can see the horizontal and the vertical in the navigation display. You can see the horizontal and vertical profile of the aircraft as it flies, and the HSI you can see the horizontal situation indicator, the magnetic heading and track, and also the decorated display of the aircraft, of the flight plan of the aircraft. So we can see the flight plan. We can see also the waypoints later. We're going to select some waypoints using the flight management computer. They're going to be displayed over there in the navigation display with a purple line connecting them. The legs of the waypoints of the route of the aircraft. Also we can see over here in the navigation display, you can see the horizontal and vertical profile of the terrain. Around you can see the terrain displayed with red, green and yellow, or magenta, and yellow and amber indication color. So we can see also you can see the lakes, the rivers and the sea displayed with blue. We have also the magenta color of the flight plan. You will see later when we're gonna create a flight plan we have to follow the route also in the horizontal and the vertical flight plan, and also we have to avoid the terrain around us and in front of us using the vertical display and the horizontal display of the terrain and weather reflections from the weather radar. You can see also the airports where they are located in the terrain map. You can see the 4-letter ICAO name of each airport. Our own airport, the Lszh in Switzerland. Also you can see the taxiways and the runways from the GPS receiver. We have the latitude and longitude of the aircraft position. We use the inertial reference alignment. For that, using the flight management computer and the iris panel in the overhead panel, we need to align the aircraft. We have also the magnetic north pole and the geographic north pole, and the magnetic variation depending on where we are in the world. We can see also the navigation aids, the world stations, ADFs displayed in the navigation display. Also the waypoints which are horizontal and vertical navigation fixes, and altitude and airspeed constraints. The aircraft is gonna have to fly through some waypoints on this flight. Also Also, you can see we have the ACAS, the Edge Education Equality System display. You can see the engines indications. You can see the autopilot flight director system panel, the flight management computer over here. So we're gonna solve the aircraft systems before going into complete flight. So we're gonna have a complete flight from takeoff, climb, cruise, descent, approach, and landing. With this aircraft, the Boeing 787. In the end part of the video, you'll see the full manual flight. I will fly manually the aircraft, so stay with me until the end part of the video. I will show you first all the aircraft systems, and also make an engine start demonstration, set up the flight management computer, the autopilot flight director system panel. So now we have to continue the rest of the systems here. So you can see here we have also the displays. I have to show you also the flight controls of the aircraft. Use this size stick, the Lszh Extreme 3D, for controlling the flight controls of the aircraft of the Boeing 787, which is identical to the Airbus aircraft size stick. So we can climb and we can descend. We can make turns to the left and to the right. Also use the rudder pedals over here. So we can see we can climb using the elevator, is the side stick back and forth, the control wheel, left and right aileron spoilers, and the rudder pedals. We have the rudder pedals to control the vertical stabilizer, and also the nose wheel steering over here. They're interconnected in the ground for takeoff and also for landing. So we can use the rudder pedals also all the tiller to deflect the forward nose wheel like 76 degrees depending on the airspeed of the aircraft. So you can see also, I will show you now the outside view of the aircraft and talk to you about the Newton's physics, aeronautical and aerospace engineering, and derive some principles we need to know for flying the aircraft, for the air transport pilot license and the commercial pilot license. So you will see now. So you will see now the outside view of the aircraft. You can see over here you can see the surface area of the wings hold the weight of the aircraft. When we fly, the weight is divided over the surface area of the wings. So also we have the thrust vectors from the jet engines, the propulsion of the aircraft. You can see we have the exhaust cones over here, the nozzles of the exhaust of the jet engines, and also the bypass air section from the front fans. So we have the high pressure compressor and turbine over here section, and the low pressure compressor and turbine in the front fan front stage over here. Also we have the fans and also the fuel lines over here, the fuel feed from the engines, from the wings, actually from the wing tanks over here. So we have the left and the right wing tank over here, and also the center tank over here. So we have the aerodynamic chord of the aircraft wings over here, which is 23% of the Mach, where the maximum aerodynamic lift occurs for this jet aircraft. You can see also is where we have the center of pressure moving back and forth in the top surface of the wings, and also we have where the main aerodynamic chord is, also is the center of gravity approximately over here, where is also the fuel located. So we balance the fuel, the aircraft in flight using the flight controls system. We can climb and descend, make turns to the left and make turns to the left and turns to the right like this, using the rudder pedals. So you can see here Also we have the aerodynamic chord position. We have this is the vertical axis, where is the center of gravity, so we can control the yawing axis using the rudder pedals like this. I have the side stick, the yawing axis of the aircraft, the rudder, which also controls using the rudder pedals I saw you inside. Over here you can see the rudder pedals. So it's left and right rudder pedals, also the nose wheel steering over here, the tiller. So the rudder pedals are interconnected, like with the tiller and with the nose wheel steering. Over here you can see the forward nose wheels. For airspeed like from 0 knots up to 45 knots, we have only the nose wheel for control. In directional control, it deflects like 76 degrees left and right deflection, and also above 45 knots, like 70 kilometers an hour, we have the rudder aerodynamically effective over here. It becomes aerodynamically effective, so we can control some nose wheel steering with the rudder in takeoff and in landing when we do the inverse. So it decreases the nose wheel steering deflection from 76 degrees to like 7.6, either left and right direction. And also you can have more rudder as you increase the airspeed. So at 80 nautical miles per hour in takeoff, or in the inverse when we land and you decrease the airspeed, so at 80 nautical miles or 140 kilometers an hour, we have the nose wheel deactivates and there is zero deflection. So we have only the rudder for steering the aircraft in the takeoff above 140 kilometers an hour or 80 knots, 80 nautical miles per hour. So you can see the rudder, the yawing axis, also the nose wheel, as I explained you right now, the forward nose wheel. You can deflect alongside with the rudder pedals. So this is how we use the rudder pedals. Also in flight you have only the rudder, you have in the ground both rudder and nose wheel for some airspeeds. So we have also another axis over here. We have the lateral axis from wingtip to wingtip, so we can deflect the side stick in the Airbus like this, as you can see. So the Airbus side stick is up, back and forth. Is the yoke over here in the Boeing, back and forth. So it's the same flight controls. There is no difference, same function. You just move the yoke or the side stick in the Airbus or the yoke in the Boeing back and forth, and you move the elevator so you can climb and descend. You have the pitch axis of the aircraft. So you have the yawing axis with the rudder pedals and the pitch axis with the side stick or the yoke of an aircraft. You can see the elevator over here moving up and down, so you can climb back side stick in the Airbus or yoke in the Boeing, and forward side stick in the Airbus or yoke in the Boeing. So you can see the deflection is proportional right now to the side stick deflection. So you use the tail for climb descent. We have also the horizontal trim stabilizer. We can trim the elevator trim. So we have this elevator trim switch here, and the alternate, the normal and the alternate, and the cutoff switch for the auto trim system. So I will talk to you. I have the trim system over here in my side stick. So I will keep talking to you about this is also another axis, is the longitudinal axis from nose to tail. It transverses the others, the vertical and the lateral axis. So this is the aerodynamics of the aircraft. You can see the longitudinal axis actually is the side stick in the Airbus, left and right. You can make turns left and right around the longitudinal axis using the side stick left and right deflection, or the ailerons and spoilers in the Airbus, or ailerons, spoilers and flaperons. Also you have the flaperons in the Boeing. So you use the control wheel in the Boeing to make the left and right ailerons and spoilers like this. So you use only the control wheel for this, or the side stick in the Airbus, control wheel in the Boeing aircraft. So same function, side stick or control wheel, also climb descent. You can move all together, full flight controls. So side stick is the roll axis, left and right, or a control wheel in the Boeing. You have also full flight controls together, all axes of controls. Using the elevator rudder together. So also we have here finishing the aerodynamics. So you can see all flight control side stick deflection is proportional to the yoke deflection over here. Also both the captain and the first officer flight controls move together in flight. They are interconnected in the Boeing aircraft unless we have some kind of failure. They're not like in the Airbus. You have the side stick priority button for either side, and you have the autopilot disconnect. You have the horizontal trim stabilizer here and the autopilot disconnect also in the Boeing. So I'll show you these switches. So we have also if you have failure, if you want to override, you have to use some force in either side in the Boeing aircraft to take more control. The override force. So finishing here the flight controls sections. So I'll talk to you about that. The aerodynamics, you can see here we have the bottom surface of the wings is more flat than the top surface, and we have the flaps extended right now, which increases the surface area of the wings, make it more flat. So you can see as we accelerate for takeoff like 250 kilometers an hour or 150 knots. So we have the airflow using the Bernoulli theory. Fluid is moving slower below the wings, which pressurizes the aircraft weight and wings up into the air. We have higher air pressure below the wings. So we have differential pressure between the lower and the top surface of the wings. So this pressurizes the aircraft weight and wings up into the air. Also the top surface, you can see, is more cooled over here. We have a higher airflow, faster airflow above the wings. Actually, it's the same airflow but faster. So we have lower pressure above the wings, which sucks the aircraft weight and wings up into the air. So you can see also we have the aerodynamic cord. Also we have the stall. The airflow becomes detached above the top surface of the wings when we fly. So you need to monitor over here in the primary flight display where is the airspeed indicated. You can see the airspeed here, the airspeed tape. So I'll talk to you about these things now. Airspeed indicated. You can see the stall speed displayed with an amber and red indication down here when you fly. So you need to apply more thrust and push the side stick down like this, or push first the side stick or the yoke down and then apply the thrust. It's maybe better action. First push the yoke down and then apply thrust. Also maybe need some rudder pedals to avoid the stall to regain control. So I will show you a couple more things here about the systems of the aircraft, the display. So I will talk to you about the horizontal trim stabilizer right now. So you can see we have this horizontal trim stabilizer switch here. We can trim the horizontal tail of the aircraft here, the elevator. So we can climb descent like this, use the elevator side stick, climb descent. We can also trim it for balancing the aircraft. So you can see we have this stabilizer trim. We can apply either the left and the right, both inside. So we have elevator trim over here, left click down, right click up, as you can see. So you can see elevator, trim, left click down, right click over here up. So you press the switch and you can use it as an elevator for the elevator trim. So this way you trim the elevator up and you pitch the nose up of the aircraft as you fly, and this way you trim the elevator down and you pitch the nose down as you fly. So they have the same either effect for the elevator trim, pitch up and pitch down, or elevator trim and elevator trim down. So we have also the flaps over here, speed. So we have the head-up display, the clutter switch, another switch here, the control wheel, and the autopilot disengage over here switch. So you can see the control wheel and the control column, the rudder pedals, better view. So we have also the alternate. This is the normal channel. So we have the flight control computers over here in the overhead panel. You can see this guarded switch, primary flight control computers here in the auto position or disconnect. So we have flight control computers aircraft. It has the normal, the alternate, and the direct mode of the flight control computers. Like in the Airbus, you have limits for making turns left and right, like 2.8 G loads, acceleration of the G loads in left and right turns, or 67 degrees, maximum deflection of the side stick, flight controls in the air. So we have also climb like 30 degrees and 1.5 G's, and also in the descent you have minus half G and minus 15 degrees. This is the limits for the normal low with the flight control computers on the Airbus. So we have the Boeing also has some identicals. Also the Airbus has the alpha protection, some overspeed protection, and low speed, and some turns also. So we have here this is the normal flight control channel. This is the alternate trim channel over here. So you can use this also if you feel there is a failure with the normal. So you can trim the elevator of the aircraft as you fly either up or down. Alternate pitch trim. So this way you trim the elevator up, this way you trim the elevator down, and you pitch the nose up and you pitch the nose down like this. So this gives this aerodynamic effect in the air. It's not like you have also the parking brakes over here, as you can see. So you can see how many degrees you deflect either here the elevator this way. You can see how many degrees over here in the display you have trimmed the horizontal elevator. Now it's 5 degrees, pitch up for takeoff and flight, stabilizer trim. Also we have the rudder trim, the flaps are extended, the landing gear down, the cabin pressurization, gross weight, total fuel on board. So also you also displays what it's the meaning of the systems display. So we have also, you can see here, we have a fly by wire aircraft. So we have the flight control computers to control the aircraft flight controls in the air in terms of G load and deflections requested from the flight controls, the control, the yoke and the rudder pedals, also from the autopilot flight director system panel, the auto throttle and the flight management computer commands. So we have a flight, if we have a failure of the hydraulic system that affects the movement of the horizontal stabilizer or the elevator control for trimming from the auto trim system. We're going to be having a malfunction of the system, so we need to come here and disconnect this red guarded switch. So the autopilot flight director system panel mainly is for controlling the auto trim system. So you can see here we have the hydraulic left and right engine driving and electric C1 and C2. We have a failure. It will fail. Some of the flight control computers will be degraded from normal maybe to alternate or direct mode, so we're gonna have a more function of the auto trim function. So this is for all Boeing 737, 747, 757 over here, and Boeing 767, also Boeing 777 and Boeing 787. We open this red guarded switch, the left and right horizontal stabilizer elevator actually from normal to cut off, as you can see. So we lose the auto trim function from the horizontal elevator of the stabilizer of the aircraft, of the horizontal stabilizer. So we use only the alternate over here, the manual actually pitch trim. So this was the automatic cutoff. This is the automatic trim cutoff. This is what's left over after is the manual. So you can trim manually all the time, no problem with that. Maybe you cannot use the autopilot like this, but it's no problem, we fly manually. So you use also the manual all the time here in the control wheel, and you see it displayed here, and you can see the elevator trim over here. You will move the elevator up and down. Also, as you move the side stick or the yoke of your aircraft when flying either Airbus or Boeing, you can control the elevator trimming. So some aircrafts have the elevator trim wheel here, all their models. This one has switches because it's newer model. So you can see also, I'm gonna show you one more view of the flight controls of the Boeing 787 in one more view, and then I'm gonna show you the flight management computer. I will set up the flight plan over here, so you're gonna see now a nicer view of the flight controls of the Boeing 787, and explain you a little bit more of the functions, also the thrust control, and the primary flight display. So you can see here we have the Airbus joystick. We have also the mouse pad here, the computer that I'm controlling. I'm using this application, the aircraft. So this is the whole setup. Also we have this view of the flight controls. So here you can climb and you can descend, moving the side stick up and down. So climb and descend. Make left turns and right turns like this. You can see, I hope you like the side stick they have. That is identical for the Boeing 787, and for it's actually for the Airbus, not for the 787. You have the yokes over here, but it controls the same functions. There is no difference in the flight controls movement or the feeling of the flight controls. So you have the thrust control over here. You can move the thrust levers back and forth like this. How many percent of the thrust control you need, like 60-70%. You can see also an aircraft is coming for landing over here. Gonna monitor that also. So we can see we have the horizontal trim stabilizer here. So climb, descend, leave neutral. Make left and right turns. Also the outside view of the flight controls like this. Climb, descend like this. So make left and right turns like this, aileron spoilers, flaperons. So flight controls are like this. I stick to flexion proportional to the yoke. I hope you like my flight controls, the side stick I'm using, also the thrust control over here. The thrust commanded like this. So we have also the aircraft coming in for landing over here. A Boeing 737-800. Hope you like it. So this is all the flight controls lesson for tonight. We're going now for the rest of the systems. I will show you the displays and also explain you how to use the flight management computer. So I'll start with the display, the primary flight display, navigation display maybe in the end, maybe I'll set up first the flight management computer. So we'll start with the primary flight display, then I will show you navigation display. So you can see here we have the airspeed indicated, the airspeed tape, the airspeed selected from the autopilot flight director system panel, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot flight director system panel over here. Also the vertical rate of climb descent of the aircraft index 110,000 feet per minute. All the steepness, trigonometric angles increase. You can see 500, 1000, 1500, 2000, 3000, 6000 feet over here, climb descent. So when you climb, this needle moves up. When you descend, it moves down. You can also monitor the altitude and the airspeed, the stall speed, red and amber indications. The pitch ladder 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down. Also the bank roll of the aircraft, how many degrees you make turns, like 5, 10, 20, 30, 45 over here degrees of turns like this. You can see also the wings movement, the wings level over here, this L symbol. So we have also the flight mode annunciator, flight director, and crossbars, the purple crossbars, takeoff ground over here arm in the flight mode annunciator. You can see this is the commanded airspeed and altitude from the autopilot, also the heading in the HSI horizontal situation indicator, the ADF signals over here connected. We have the horizontal over here and the vertical. I will show you the profiles as we fly. So we have here, as you can see, 210,000 selected from the autopilot flight director system panel. So we have 200 nautical miles per hour, 360 degrees, heading 10,000 feet altitude selected, and the vertical rate of climb descent of the aircraft. So we can set these values, we can change them later. This is the same ones as displayed in both sides primary flight display. Also the flight director here and the autopilot, I will show you now, engage and disengage switch. You can see the other side 210,000. This side also, so you can change the values of the airspeed when we go for flight. Also you can see the magnetic heading here in geographic North Pole, magnetic North Pole. The airports you can see here is Switzerland, the France and the Germany over here. We have also the elevation above the ground level. You can see the terrain with red, green and amber color. When we're going to be flying, you can see the aircraft symbol and the altitude we have selected here, 10,000 feet above the sea level. So we need to make a few more adjustments for flying the aircraft. You can see in the autopilot flight director system panel, will show you the commands over here. Also the engines indication. We can see we have the N1 which is the low speed starter sub low pressure compressor into the turbo fan engine left and right, 19.8 in the idle. The takeoff commanded 99.2% over here. The green, red, yellow limits. Also the exhaust gas temperature per engine. The N2, which is the high speed starters, have high pressure compressor and turbine of the turbofan temperature engine, the left and right over here. High speed starter shaft, high pressure compressor and turbine. The fuel flow per engine per hour 1000 kilograms, 1000 pounds. Right now it's thousands of pounds. Oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So we have the landing gear here, extended retract, not related to the engines. Alternate gear over here, standby instruments, and the auto brakes, rejected takeoff or landing. Over here we can set the auto brakes, it will display. So we have flaps, horizontal stabilizer, rudder trim, and the outflow valves of the cabin pressurization system. Over here you can see cabin altitude, rate of climb descent, differential pressure, landing altitude, outflow valves open and close. So when we climb to like 43,000 feet, the cabin altitude should be only climb like 7, 6 or 8,000 feet, and the differential pressure should be like 7.8 to 8 psi. So we open and close the outflow valves. In the automatic or in the manual, we use the outflow valves to increase or to pressurize and depressurize the cabin. In most aircraft, they receive a pressurizer from the 5th and the 9th stage from this setting of the engines over here. The high pressure compressor turbine, we have the 5th and 9th stage. Also we have the front fans is the bleeder, so it supplies the cabin pressurization, and the wing and edging the eyes over here. So we have wing and edging the eyes. So we have bleeder from the engines for that. So we have the bleeder in the Boeing 787, maybe cabin pressurization. Use the outflow valves like this, climb descent. We saw you also in the manual control later. It supplies also air conditioning, ventilation, oxygen in flight, and wing and edging at the ice, and the hydraulic fluid tanks pressurization. So we need many systems. Also we have the APU here to start the engines in a couple of minutes. So we'll set up first the flight management computer for going into flight. We need the flight management computer. So I'll show you how to set up the flight management computer right now. So all the systems you see here from the engines indications, like the N1 and 2, fuel flow, are control from the FADEX. The FADEX are the full authority. These are electronic control computers, one installed per engine gearbox, dual channel redundancy, one channel phase, the other takes over, controls motion displays all the engine data you see in the upper and the lower ACAS, or in the multifunction display. Also it controls the fuel flow to the engines, engine start, engine shutdown, engine failures. Also the outflow air from the engines for regulating the pressure inside the engines. Also as we climb to higher altitudes, we have the pressure of the air and also the density and the oxygen of the air become less than half than that of the sea level, like in 20, 30, 40,000 feet above the sea level, like 7, 8, 9, 10, 11, 12,000 meters above the sea level. So as we climb higher, also the temperature of the air becomes freezing, like -30, -40, -50, -60 degrees. So we're gonna be having an airspeed like 2 or 3 times faster than that of the sea level. So we're gonna be having a different fuel mixture request every second. This is adjusted by the FADEX, by the full authorities electronic control computers, the fuel mixer. Also when we descend the aircraft, also as we climb higher, the fuel and the oil and the lubricants will freeze. The fuel will freeze at -37 degrees, so it can recirculate the fuel from the left and the right wing fuel tanks and the center tanks into the engine components to heat up the fuel, also the lubricant and the oil, and this is done also automatically from the fatigues. The fatigues also have other calls. We don't have enough time right now, so I'll show you now the flight management computer. I'm gonna set up the flight management computer. I will set up the takeoff gross weight of the aircraft. That includes the empty weight plus passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing. In the center tank, so we have 30% in the left wing tank and 30% in the right wing tank and 10% in the center tank. The flight management computer is going to calculate automatically the center of gravity of the aircraft during the whole flight. We burn fuel, so the center of gravity is recalculated. Also, we change the attitude of the aircraft in flight. So we make this is done automatically from the flight management computer. Also, the main aerodynamic core position of the aircraft, and also the angle of stall. Also, the horizontal trim stabilizer position from takeoff, climb, cruise, descent, approach, and landing. Also, we have the takeoff speed. We select the runway we're gonna use for takeoff and for landing. The Lszh Zurich International Airport in Switzerland. So we're gonna use this runway 14 for takeoff and for landing. We're gonna select the runway length and runway slope. The wind direction, the speed, the barometric pressure, and the density of the air is gonna give us the takeoff speeds V1, V rotate, and V2. So you're gonna see how we're gonna do that. I'm gonna use the flight management computer to set up the flight plan. I have also here this mouse pad to control the flight management computer. We have our own mouse pad in the aircraft. You can see here this screen, so we can control the screen displays here, like identity, position over here, performance, takeoff, approach, and unseated status. So we have I'm gonna show you now flight plan. I'm gonna set up the flight plan over here. So go in this display over here, show you the flight plan, how to create a flight plan very quickly. So in the control quadrant you can see the mouse pad again, the display over here, flight management computer, also the autopilot flight director system panel. So not losing too much time, so we have the identity of the aircraft is Boeing 787 GNX engines and the Iraq cycle, the position Lszh Airport, Zurich International Airport, and the alignment, inertial reference alignment, the index, position, performance, zero fuel weight and fuel on board, gross weight for takeoff, and the cruising altitude over here, cost index, fuel freezing temperature, and the center of gravity in flight. So we use the departure origin here, airport Lszh in Switzerland, departure destination here, copy paste, and also set the runway for takeoff and for landing, runway 14. So we have departures over here, set departures. We can select runway 10, 14, 16, 28, 32 over here, either runway for departure. As you can see, Lszh departures. Hope you can see more clearly. Select the runway 10, and also the standard instrument waypoints and fixes, standard instrument departures. So we have the departures here set. We can set the arrivals now for completing the flight plan. We have the approaches. So we can set approach VOM 16 to 8, 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. We're gonna set ILS 14, Transami key over here, and the stars is other terminal arrival waypoints and fixes. We're gonna set the Negria 1 alpha. So we have the complete route right now set. You can see it's not yet activated, it's displayed with blue. So we have the first waypoint after takeoff, the heading and the airspeeds all the way up to the Zurich, Negria, Mativ. Then we have discontinuity, then descent Zurich 701, approach and landing. So we go here, initialize the performance, zero fuel weight plus fuel on board, gross weight for takeoff, the reserve fuel 5%, and the cruising altitude for this flight. It's gonna set the performance and the cost index. We have also fuel freezing temperature minus 37 degrees over here, and the center of gravity in flight. So this we can activate now the legs and the route. You can see first waypoint, second we make a left turn here, climb to Zurich, it's 6 nautical miles from takeoff, 301 knots, 6000 alpha. Then heading 071, 26 nautical miles, 301 knots, flight level 22,200. It's the Nigria. We make a right turn there, 12 nautical miles is the Mativ, then 6 nautical miles Amiki. We descend here, 180 knots, 7,000 Alpha. Zui, make a turn, Zurich 701, 6 nautical miles over here. TRA 290, 10 nautical miles. CI 14, 6 nautical miles also. And here we make a left turn for alignment with the runway, 5 nautical miles. We have also the ILS localizer set over here for approach and landing, and Zurich airport here in runway. We use flaps for takeoff, 15 degrees. Center of gravity over here, takeoff reference, and the V speeds, takeoff V1, V rotate, V2. We have also alternate VNAV, progress, hold, fix, and navigation radio. So we go back in the first over here. We set we have to set up to start the APU right now. So going the overhead panel, you can see we have the switch. We're gonna turn it on. The electric is the auxiliary power unit we need for starting the engine. We have 100 to 200 volts, 400 Hz frequency, 120,000 kilovolts left and right engine driving. The batteries, primary flight control computers here in the auto position, heading reference over here, IRS flight control surfaces, battery, town power, FD door, passenger oxygen over here, window heat, rammer turbine. We have the hydraulics, left and right engine driving, electric. So we turn off, you will see the fault display, turn back on the hydraulics, the left and right engine driving. We have here the wing and engine RDIs over here, as you can see, on or auto for this flight, not off. We have here also we have the recorders over here. We have the APU and cargo fire, the recorders. We have the electronic engine control for the engines over here, the auto start, and what controls the normal, the alternate mode, the farex. We can dump some fuel in flight and lose some weight, select the nozzles and how much to remain. We can use the fuel booster pumps left and right, wing and center tank, the crossfeed valve. We turn it on, can feed either engine and balance the fuel with other pump or either tank. So also we have the cabin pressurization over here. I told you before, in the manual mode we use the alpha valve, so climb descend. In the automatic we have to do nothing. Pressurizer also from the engines, APU, cabin pressurization, oxygen, hydraulic fluid tanks, and wing and engine eyes. So we need also one last thing before going to take off. We're gonna see the systems I just saw you very quickly over here. We can see the display here. We have the hydraulics, the APU is running, the oxygen and the liquid cooling over here, the electric, left engine and right engine IDG, the drive with the APU is running, 120 to 200 volts, 400 Hz frequency, the load, and the battery and the main and the APU battery over here, voltage and average. So we have also the hydraulics, where the hydraulic fluid goes, which systems use it. Also left and right engine, primary demand, C1, C2 electric over here, and also the quantity of the hydraulic fluid and the pressure 5100 psi over here. So this is the hydraulics, the fuel, left and right wing fuel tank, 11,000, 11,000, 10,000 in the center, total 32,900. The low and high pressure fuel valves are open, left engine, right engine, and feed from the center of the wings. Also the crossfeed valve is off, but with the net one can feed the other engine without a primary tank. The APU is fed from the left wing using the DC motor. Also we can see here the minimum fuel temperature, minus 37 degrees, below which the fuel will freeze in flight. So we recirculate and the fuel temperature right now, so we recirculate automatically. The fuel also, we can balance the fuel with the crossfeed between the left and right wing. Pressurizer from the packs and the engines, doors are closed, the cabin can be pressurized. Landing gear, the temperature of the brakes and the pressure of the tires. Flight controls, over here you can see the movement of all flight controls, the tail over here, the elevator, climb descent. So this is one of the last things we need to check, the flight controls over here, movement. Also we have FIS display over here, maintenance over here, also circuit breakers is digital, and the checklist just before going to flight, what to do before after takeoff, descent, approach and landing. So we go back in the navigation display, we turn off both engines over here for going into flight, both engines, fuel flow in the off position like this. So you will see what happens over here. It will display some faults, fuel starvation, the N2 is decreasing, the amber message in the ACAS. So we have the jet aircraft, a beautiful jet. So you can see over here the engines are off, so we need to restart them very quickly. Over here both auto start in the on position like this. So you see the amber switches lights on in the overhead panel for the auto start. So we have pressurizer right now into the engines. The N2 only receives pressurizer for the engine starter, so above 20% of pressurization, 20%. So we can let the fuel flow right now on like this, both fuel control like this on. So we have the engines on in a couple of seconds. Auto start is kicking in, as you can see. So we have 38, 51% over here. You see the amber messages going off. So we keep having more pressurizer and also fuel right now. So we have the engines running at 62%. Also we have the auto throttle here left and right. Auto throttle left and right. Autopilot disengage. Flight director disengage the LNAV over here. So we set the LNAV, VNAV over here. The airspeed for takeoff. And also heading over here we can set the heading of the runway very quickly. And the climb over here we can set a descent like this, or a climb. Gonna set climb at 3,500, and also the altitude here. Very quickly. So we're going for takeoff. We're ready for takeoff. Flaps up over here. Speed brakes up, parking brakes off, and we advance the thrust levers and we taxi to the runway. We take the clearance from the air traffic control like this. So we have the runway open for us for takeoff. There is no other traffic from the air traffic control. Also we use the tiller here for steering control, for alignment with the runway. Idle thrust right now. So tiller like this. So we advance the thrust levers all the way up the takeoff ground position and push down the yoke until 100 knots. So now we have like 60 knots, 70, 80, 100 knots, yoke up, 120, 130, V1 over here. We rotate 9 degrees, pitch up. So we pitch up only 9 degrees or less for takeoff rotation. So we have the positive rate of climb, gear up, and we keep climbing at this positive rate of climb. Quite easy. You can also leave your flight controls like this off, no problem. when climbing. This aircraft won't go off its way. So you can see here, we are 2100, 2200, 300, 2400 above the ground, but 4000 above the sea. The airspeed is 180, 179 knots. The stall speed here with amber and red indication. Also you can see here the altitude and the rate of climb. We climbed with 4900. The pitch altitude, to decrease the stall with red we need to avoid the stall, so we pitch down the aircraft slightly like this. Also you can see the wind direction and speed, the flight plan, the terrain with green, yellow and red. So you can see the aircraft symbol. We're flying like 3000 feet right now above the ground over here. So you can see the terrain below us. You can see the terrain is 4600 over here above the terrain level. Also you can see numerically how many thousand feet we are above the ground. We can see also further away, you can see the engines also right now indications, and further away you can see with green, red and yellow, and also the flight one as we fly. Look closer and look also outside. So we need to make the turn now. So we have the airport here, the runways and the lakes here, Switzerland. So we need to make a turn over here. So we turn and keep climbing. Also look again outside over here. So hope you like the view of the aircraft right now as we are overflying the Switzerland. We have one of the most beautiful views here. The lakes and the Swiss Alps. Also going to be overflying here the Germany, the France. So we keep flying over here, the flight plan also. So you can see the view of the aircraft cockpit just after takeoff over here. You can see the displays also. The engines data here, the flight plan, the air data. So we have 163 knots, the stall speed here, the wind direction and speed over here, the ground speed of the aircraft, the next waypoint we have to be overflying. We are like right now 9,900 feet above the terrain. Keep climbing. So we need to fly over these waypoints over here. As you can see, this flight one. You can see the whole flight one, both sides. The autopilot also right now. So we are 16,000 feet. Keep climbing. So I'm gonna make a turn over here, align with the flight one, with the LNAV flight path over here. As you can see. So we have like a few more minutes to go back to the airport. Like 10 more minutes left for this video to end. There's no problem, leave your hands off the flight controls. No problem for the aircraft, can handle very well. So we have the outside view again, and we overflying here the France, my homeland Germany in front of you, Bayern Munich also, Bavaria, and here the lakes, the Swiss Alps over here. So we're gonna make a turn now, start the turn. We're going back to the airport. So you can see we can use also some right rudder to make more steep the turn. And see we have to follow the flight plan. Hope you like over here we're flying the Germany, Bayern Munich, the France, and the lakes. So this is the Boeing 787, almost 22,000 feet above the sea level. So we need keep turning over here. The flight plan, align with the flight plan over here. Use a bit more right rudder for alignment. Keep climbing a little bit more, 22,000 feet or 7,000 meters. We overfly now Switzerland again, leave Germany behind us. So 7,000 meters with the beautiful jet aircraft. Hope you like the jet aircrafts like I do. So we need to follow the flight plan over here one more time. So we have here the chemtrails frozen. Frozen vapors over here. So this is the beautiful view over here, overflying this beautiful. You have the galactic view here, the Boeing also 787 overflying this level. So we need to start the descent now. You can see the lakes here, the France on this side. So we start the descent, idle thrust over here. And speed breaks down. So we need to increase the airspeed now as we are descending. And we have a few more minutes to land. Increase the rate of descent over here, and also align with the flight plan. So hope you like the view again from the cockpit of the Boeing 787 as we are descending. So we make a turn over here, keep descending. Need to follow these waypoints over here. You can see also the runways, we have them behind. And we have 3 more minutes for approach and landing, so we need to keep more steep descent over here. And also make the turn here. More steep turn over here. Keep descending also. So you can see we're gonna make a shortcut over here for approach and landing in the airport. So we are almost for alignment over here of the runway. Need a few more minutes. So we are a bit high. We need to increase the rate of descent over here. And use some flaps also. So we're gonna make an F-16 fighter jet approach and landing over here. So we are almost aligned over here. We have some side wings, some whip gas. So here we are, touchdown, very beautiful touchdown, landing gear.